welcome everyone. Thank you so much for bearing with a little bit of technical weirdness as we attempt this new system here in our collaboration with GMAT Club. And thank you again to GMAT Club for hosting us, for giving us this platform to be able to chat with you guys about one of my absolute favorite data sufficiency question structures to tackle, because it's one that many of my students will struggle with early on before they know to look out for it. It tends to kind of fly under the radar very frequently, but if we know what to look for and we know what to look out for, it's an easy opportunity for improvement. Now, I'm giving everyone who's watching live the opportunity to catch back up to speed, but please, by all means, jump into the chat, introduce yourselves, let us know where you're tuning in from, and we'll kind of get things rolling, get things started from there. And I will say, with this particular topic area, I've been a little intentionally elusive about it. Haven't entirely jumped into what it is we're going to be talking about right up front, and for a reason, because I want to make sure that you guys are able to jump in kind of unobstructed to an introduction question and see how you fare with it. So by all means, jump in. Thank you guys for introducing yourselves, and thank you guys once again for your patience. Both those of you who tuned in yesterday to find the reschedule, and today here in our Central Florida studio, we've been circling back up to speed from some hurricane after effects and have been without power and internet for a little while. So thank you so much for joining us, everyone. And what I'd like to do is I'd like to actually not preface this first question at all. I'd like to let you guys dig right into it. And for those of you with some level of concern, I will note none of the questions we will be going through today will obstruct any of your practice tests in any regard. These are all either Veritas questions or older version official guide questions, so you'll be in good shape there, no need to worry. So without further ado, I want to go ahead and dig in and let you guys take a look at an introductory question. Now, I have made a particular assumption here, and I've assumed along the way that everyone's comfortable with what answer choices correspond to sufficiency versus insufficiency in each statement. I figure all of my GMAT Club folks tend to be pretty on top of that. If you're not at that point, if you don't have some sort of a structure, whether it's your 1, 2, 10 or your kind of flow chart or a table of outcomes, then please feel free to set something in front of yourself. But otherwise, I want to save the valuable board space for the question itself. And what I'd love to have you guys do is just take 2 minutes just to try to peruse through this question, just to try to route through it. And we're going to toss a link into the chat for you guys to give me your responses so that we're not giving too much away along the way here. So let's go ahead, let's take 2 minutes, and I'm just going to let you guys introduce this one yourselves, and we're going to circle back and actually follow up with takeaways here. So I will see you all in 2. right, let's go ahead and jump back into things. So we have some pretty mixed responses, and if you haven't had the chance to jump in with your answers either in the chat function or in that poll, definitely feel free to do so because we're gonna get chatting about this one. And I will say, you guys have actually beat out our usual statistics on this question, maybe by virtue of the fact that I've given a little bit away with my title of today's lesson, and maybe because you've routed effectively through this question. But let's go ahead and talk about what I mean by this idea that the collective is the objective, right? So in this question, I'm asked if triangles ABC and CDE are each equilateral, so potentially not the same respective size as one another, but we do know, based off the fact that we have two equilateral triangles, that each of my sides of ABC is the same, so let's call that X, right? And each of my sides of CDE is the same, so we could call that Y. Then what is the question asking us for? If it asks us for the sum of the perimeters of the two triangles. So it's asked us for a sum here. The sum of the perimeters of the two triangles. In terms of the information I've laid out here, what is this question asking us for? Feel free to just jump into the chat function on this one. So the sum of the perimeters of the two triangles, how could I set that up algebraically? That's exactly right. I'm looking for 3x plus 3y, or 3 times the quantity x plus y. And it's absolutely vital that we take this step so that we can keep in mind when we've gained sufficiency, right? Data sufficiency is all about resource management and resource utilization. And so we want to recognize as soon as we've hit the point where we have enough information to answer our question, because many students, and I will say it's actually generally over 50%, you guys lingered a little under 50%, so super encouraging there, will tend to conclude, well, statement 1, line segment AE measures 25 meters. Well, this 25 tells us our length here, but it doesn't tell us the relationship between the two. And hey, side BC, if I know both of these pieces of information, I can solve for both of these side lengths, and thus I can solve for everything about the situation. But the question hasn't asked us for everything about the situation. The question has precisely asked us to answer the question, what is the value 3 times the quantity x plus y, or what is the sum of the perimeters of the two triangles? And while it may seem counterintuitive at first, anytime a question is asking you for a sum, a product, a difference, any sort of collective unit of information, it's generally easier and requires fewer resources to solve for that collective as a unit than to solve for each individual element and put it all together. So if a question asks us for x plus y, I almost certainly want to be looking for an opportunity to isolate x plus y as a unit rather than solving for each individual component and then putting them together. Because if line segment AE measures 25 meters, what has that told us in the context of the algebra we've built here? What does 25 correspond to? Anyone have thoughts for me? If AC plus CE gives me 25, well then 25 corresponds to my value x plus y. That's exactly correct. So if I know that x plus y is 25, I can certainly solve for 3 times x plus y, whether I laid it out algebraically as we did here, or maybe you thought about it a little more conceptually and said, all right, well, if AC plus CE gives me 25, then so does the sum of DE and BC. And so does the sum of AB and CD, right? But the key to keep in mind here was that we weren't being asked to solve for each individual length and put it together. We were asked to solve specifically for the sum of the perimeters. And at that point, statement 2 was here to trap us. It was here to trick us into buying more resources than we needed, because very clearly once we put this information together, we can solve for everything, but we didn't actually need it to get there. So in this case, statement 1 on its own is sufficient. Statement 2 is not necessary to draw this particular conclusion. So those of you who chose A, very, very nicely done there. You are absolutely correct on this one. Those of you who chose C, we want to make sure we're taking a quick step back and thinking about answering the question that's being asked, not answering absolutely everything. And I will say, as a quick kind of pattern recognition tip, if the two statements together appear to very clearly and obviously give you a full sense of the situation at large, double check. Make sure you're not buying into more resources than you need, because in many cases, they'll try to trick us into seeing the clear and obvious overlap when we didn't necessarily need it. So when I mention this idea of when the collective is the objective, when we're being asked for a collective unit of information, right? Whether it's a sum, a difference, a product, whatever that may be, make sure you're attempting to answer the question being asked, not to answer everything about the situation at large. And we've got a couple of kind of miniature takeaways built into the rest of the lesson to that effect, but I will say, we're now at a point where we're kind of hand-holding you through this lesson because I've told you that this is what we're going to be looking out for. Now, I'm going to move us into some more challenging questions that deal with this particular concept, but we'll want to make sure along the way that you guys are on the lookout for particular cues, particular indicators, and for seeing the way the question stem is framed so that you're able to recognize in your self-study, in practice tests, and on test day when you're being asked for a collective unit of information and how it might be easier to solve for or isolate that unit than to solve for the situation at large. And I want to go ahead and have us look at that in the context of a second question. Now, by all means, if you guys have questions or qualms as we're moving through this, jump into the chat and let me know. I'm following along with the chat here, so feel free to jump in with questions as you have them. Otherwise, let's take a look at a second example. So I've got the first couple of these questions are 650 to 700 level questions. The final couple will be 700 plus level questions for those of you challenging question enthusiasts who are ready to power forward into those. So once again, let's take 2 minutes. I'm going to let you guys lead the way, see where you get. I'll reset the poll, so if you guys can jump into the poll so we're not giving too much away in the chat, please feel free to do so. And then we're going to talk about this question asking us now, what is the value of m plus n? All right, so we have hit on our 2-minute mark, and at least for those of you participating live, you guys have destroyed the usual statistics on this question. You've done quite well. Let's go ahead and talk about why. So, if the question is asking us what is the value of m plus n, again, when we think about the fact that the collective is the objective, right, we can notice here that it may very well be easier to solve for the value of m plus n as a unit than to solve for each element individually, because individually our general, case rule of thumb tells us that when we're looking at linear equations, we need a certain number of unique linear equations for that certain number of variables if we're attempting to solve. But the GMAT is almost more prone to test the exception to the rule than to the general case formula itself. So even if we weren't looking at this in the context of the lesson, and you didn't initially jump out and recognize right off the bat that we're trying to isolate m plus n, hopefully statement 2 gave you a pretty clear indicator, a pretty clear cue as to how you ought to move through this question. Because j plus k being equal to 12 on its own doesn't tell us very much, right? We don't have any context for what j plus k equates to if we're looking just at statement 2 and at our question stem. However, it gives us really good indication of how I might want to manipulate my first statement. So while we don't want to let information from one statement kind of creep into the other in our analysis, we want to avoid that carryover effect, we will want to make sure along the way that we look out for cues, for indicators, for hints that they may be trying to tell us in the alternate statement. So in this case, if I know that j plus k equals 12, and I will say individually neither of these have a chance of being sufficient, but let's talk about them together, which is what most of you correctly concluded. So together, if I'm looking at these two elements, if j plus k equals 12, and I have in my first statement here jm plus kn plus jn plus km, what might I do to start to simplify and to have a fighting chance of isolating for the value m plus n? What might I do to get there? Just in a word or two. And again, I'll lead the way through it, but I want to make sure we're all thinking on the same track here. So if I'm looking for the value of m plus n as a unit, and I have jm, kn, nj, km, right? Well then I know I have some elements that I can put together, I can find those common variables, that's exactly correct, and I can factor, and in this case I can factor by pairing. I can rewrite this to recognize that in this case I have jm plus jn plus km plus kn, and at that point, I can factor out what I have in common. Well, I have j times the quantity m plus n, and k times the quantity m plus n, and I know all of this is equal to my total of 36. Now, you may have chosen to factor by pairing in a different order, and that's perfectly fine as long as you're arriving at the same answer, at the same result. So at this point, if I have an m plus n in common between both of my elements, I can factor that out and arrive at j plus k, the quantity, times the quantity, m plus n, and I know that's all equal to 36. So if I'm trying to isolate the value of m plus n, on its own, I'm not able to do so. But if I know the value of j plus k equals 12, I've now set myself up in a position such that, all right, well, if j plus k just gives me 12, and 12 times m plus n equals 36, well, then I know the value of m plus n, it's 36 divided by 12, or 3. Now, if as soon as you got to a point where you knew you could solve, as soon as you got to a point where you recognized you could isolate m plus n as a unit, certainly in data sufficiency, we can stop there, right? We don't need to move through all the calculation. I want to make sure I've got everyone on the same page, so I've routed us through the rest of the algebra, but keep in mind, as soon as we recognize that we're able to isolate and solve for definitively one value for m plus n, we're in good shape, we're done. We can move on through this question, but as almost everyone here in both the chat and the poll function has concluded, yes, together we have enough information to answer our question. And one of the big secondary takeaways that I like a lot from this question is the fact that, yes, we do in fact need to analyze statements individually, but we also want to keep in mind we can't ignore that they often provide valuable cues or hints when we look to that analysis. So again, even if you had not recognized to factor or to factor by pairing to find those common variables in statement 1, I would have looked at statement 2 and circled back and said, wait a second, is there more I can do with this information? So very nicely done. Again, for those of you tuning in live, pretty consistently arrived at the correct conclusion here. And we want to note, along with solving for this collective unit of information, that when we have those cues or those indicators, we want to allow them to help inform the most efficient path to the answer. All right, I got another one for us. And then we're going to move into what I'll call kind of a challenge question, and then we'll take just a moment to talk about how this actually overlaps in many ways with what we think about with problem-solving questions as well, because there is some cross-application there. But for the time being, I want to let you guys lead the way once again with what is the value of x squared minus y squared. So go ahead, once again, take 2, and we're going to follow up with takeaways. All right, let's go ahead and talk about it. So I will say accuracy was very high on this one as well for those of you who responded both in the chat and in the polls. However, the level with which and the speed with which you got to that accuracy varied pretty drastically. And so that's kind of a secondary element I want us to take a moment to chat about. So a lot of folks caught up here with answer choice B, a couple of you chose C, and then overwhelmingly in both the chat and here we had a lot of you guys choosing answer choice D. So let's talk about it. So if we're asked what is the value of x squared minus y squared, I'm hoping there's something that jumps right off the screen, right off the page at you guys around this structure x squared minus y squared. What am I looking at here? Does anyone know the term? Does anyone know how I can restructure this information in a way that allows me to draw efficient conclusions on its basis? Yeah, there we have what we call our difference of squares. And I know that difference of squares can be rewritten if I have x squared minus y squared as x plus y, x minus y. And as soon as I know that that's what the question's asking me to solve for, once again, this doesn't inherently tell me I need to be able to solve for the value of x, solve for the value of y, then put all that information together. Instead, I want to think about what gets me precisely to the point where I can solve for my quantity x plus y times my quantity x minus y as a unit. And I will say in many cases, despite the fact that the GMAT is not intended to primarily be a memorization-driven test, there are certain foundational concepts like recognizing difference of squares and other common algebraic equations so that we can basically see them and swap them when we encounter them that will make us faster in questions like this one. Because if I now see my x plus y, my x minus y, universally just about everyone recognized that statement 2 is enough information to answer my question. If x plus y equals 0 and I plug 0 in to my first parenthetical, well then I know the product as a whole is 0. I can answer the question that's being asked. I know this is sufficient. Statement 1 was a little more challenging for a couple of you. So let's talk about how we can restructure what began as ultimately not that convenient of math to draw basically the same conclusion. Because if I'm looking for an opportunity, if I'm saying, all right, well, there isn't an opportunity based on this linear equation that I solve individually for each of these unknowns, the only way I'm going to have the possibility to get there is by taking a similar route to what I did in statement 2, by being able to isolate and solve for 0, to solve for the parenthetical entirely. And I can do that by adjusting what I have here, either by subtracting x to get to the fact that y equals x, or by taking things a step further, as we've seen here in the chat, and recognizing that then 0 equals x minus y. And hey, even if I didn't know this up front, if I know that the value x minus y is equal to 0, once again, I know the entire parenthetical is equal to 0. This is enough information to answer my question. So very nicely done, those of you who chose answer choice D. And again, if you're in a position to where your mind immediately routed to, oh, I have 2 unknowns and only 1 equation, so it can't be enough, keep in mind, that's a general case situation. In many cases, the GMAT is prone to test the exception to that rule, and we need to make sure we're prepared for that. And part of that preparedness comes from seeing how the math can be expressed in a little more convenient of a fashion, and making sure we know what extent of information we would need to answer the question being asked, not to answer absolutely everything about the situation. So very nicely done, guys. As always, jump in if you have questions in the chat. But the secondary takeaway that I have for us with that question, which again, you guys routed through extremely well as a whole, is that in many cases, we begin particularly algebra questions by taking inconvenient math and making it more convenient. And little elements like seeing information like our common algebraic equations and swapping them can help us to do that far more efficiently, as many of you did, particularly those of you who were able to jump in the first 15, 20, 30 seconds. This is an easy opportunity for a question to where if you have mastery of the underlying content and you know the strategies, well then we're going to be in a really good position to where we can save time on this question and allot it to another potentially more calculative or more time-consuming question down the road. So let's go ahead and take a look at one more data sufficiency question. It's one of my all-time favorites. And without prefacing it too heavily, I will keep in mind that we're following along the lines of the same trend we've been working with here. So go ahead, take 2 and see how you fare with what is the measure of angle AED minus the measure of angle ABE. See you guys in 2. All right. So our 2 minutes has passed, and this one may have been a little more of a time crunch for many of you than some of the past questions we've encountered. And primarily, I've been walking us through a couple of pretty conceptual questions that, upon recognizing the key at hand, are fairly straightforward to tackle in well under that 2 minute mark. This one had maybe a little more to it. And it asks us, what is the measure of angle AED minus the measure of angle ABE? Now, our performance is actually pretty substantially better in the chat function than for those of you who responded here. However, let's go ahead and talk about it. So first and foremost, one thing I will say is that I avoid working with these 3-point measurement systems for my angles where I can, and we pretty much always can. With very, very few exceptions, I like to replace these 3-point tiers, these 3-point systems, with just variables, unknowns that allow me to work through things algebraically. So in this case, I'm going to call my angle ABE X, I'm going to call my angle AEB Y, and I'm going to call my angle AED Z. Just X, Y, and Z here. So if I'm labeling my angles X, Y, and Z, what is the question asking me for in terms of these unknowns I've just established? It's asking me the measure of angle AED minus the measure of angle ABE. What are we being asked for here? Anyone have thoughts for me? So if I'm asked for the measure of angle AED minus the measure of angle ABE, that it's asking me for Z minus X, right? So if it's asking AED minus ABE, it's asking Z minus X. So as soon as I know I can solve for Z minus X as a unit, I have enough information to answer my question. Awesome. And that's okay. I figured it was just flip-flopped a little bit there. So if I know the measure of angle BAE, this unlabeled angle I have here is 30, then let me ask you this. What algebra can I build on this basis? What can I do to start to draw some conclusions? Well, I know that the sum of 3 angles will need to get me to a total of 180 degrees in my triangle, right? So if that's the case, then I know that the 3 angles that make up my triangle here are 30 degrees, angle X, and angle Y. I can start to build out some algebra, right? I know that X plus Y plus 30 gives me 180. Thus, X plus Y gives me 150. That's exactly right. So I know X plus Y here gives me 150. Is there a second linear equation I can build based off of this information that allows me to bring Z into the mix? Because I'm trying to solve for my quantity Z minus X. So somewhere along the way, I've got to bring Z into the mix. So what second algebraic equation could I build that will allow me to start to draw conclusions? Yes, I have supplementary angles here. Z plus Y gives me 180 degrees. So if I know Z plus Y is 180, and I know X plus Y is 150, what can I do with this information? What can I do with these 2 algebraic equations if my objective is to solve for Z minus X? Keeping in mind I have 2 equations, and that generally speaking I can substitute or eliminate very, very regularly. The GMAT sets things up such that they are very well prone to elimination or subtraction in this case. Yeah. So if I subtract these 2, my y's cancel. I end up with Z minus X, the quantity I'm looking for, and I have 180 minus 50, leaving me with a remaining 30. Awesome. So I know here that my first statement is sufficient. It's enough information to answer my question. Now let's talk a little bit about statement 2, because statement 2 tells me the sum of the measures of angles ABE and AEB is 150. Is this enough information to answer my question? The sum of the measures of angles ABE and AEB is 150. Well, ABE and AEB are just our X and our Y values, right? So this gives us precisely the same information we had in statement 1. It's just done so in a slightly different way, in a slightly more abstracted way. So in this case, I don't need to do the math all over again. I know that it gives me precisely the same information, thus I can draw the same conclusion. Statement 2 is also sufficient. So for the couple of you guys that chose one but not the other, we want to be on the lookout, because anytime Each of my statements gives me precisely the same information. I can use precisely the same info. Well, we're narrowed down to only 2 possible answer choices. It can only possibly be that each statement on its own is sufficient or that each statement on its own is insufficient if they give me precisely the same information. In this case, it was just a slightly obscured, a slightly different way of saying that this angle is 30 degrees and allowed us to draw the same conclusion to build this same equation. So very nicely done, guys. Again, accuracy was pretty strong here, but I would caution you to make sure that you're on the lookout along the way for cases to where we can work through these questions more efficiently if we know what we're asking, if we leave ourselves less error prone with these obnoxious 3-point measurements for our angles, and if we look for opportunities to eliminate and to overlap our algebra with geometry, because in many, many cases, geometry is just a layering mechanism for algebra. There's a ton of overlap between the two, and we want to make sure, and this is a huge thing I work with my students on all the time, we want to make sure we don't put on the blinders to outside content areas when we're looking at something. I don't want to look at a geometry question and say, all right, I'm looking at geometry and angles, I'm looking at geometry and angles, and ignore the potential that using systems of equations in algebra may potentially be helpful. And I will say, yeah, it's one of my favorites as well. So, with that in mind, we want to make sure when we approach data sufficiency questions and questions in general that we're simplifying what the question is asking us in a way that makes sense to put the numbers to. And this is another really big point for my folks who tend to be very time conscious as they move through questions, is that generally speaking, I know it sounds counterintuitive, but generally speaking, we save time in the long run by recognizing what the question is asking us in its simplest terms and by seeing the path to the answer before we really heavily start to put pen to paper. Because it keeps us from taking excessively calculative routes. It keeps us from going through routes on questions that won't yield results for us, and it ensures that we're adding very active value with all of the time that we're committing. All right, so I have one more question for us before I talk a couple of kind of bigger picture elements. And this one more question, you'll notice, is not a data sufficiency question, because I want to note that in many cases, this idea of when the collective is the objective very, very heavily applies when we're looking at problem solving as well. So once again, if I'm asked for a collective unit of information, I want to think about how I can solve for that unit of information together rather than necessarily having to solve for A, solve for B, and then put them together. And without too much further foreshadowing, I'm going to give you guys 2. Go ahead and jump into the polls and answer this one, and then we're going to circle back with takeaways. right, folks, let's go ahead and talk about it. So I will say, a lot of folks very much on the right track here. Our polls in this one have been overwhelmingly positive, and so hopefully, again, we are looking out for cues or indicators to where even if this weren't kind of the title of the lecture, then we would know that if we're looking for a collective A-B, we may not necessarily have to be able to isolate each one individually, and instead we can look for opportunities to isolate AB as a unit. So as it stands with these two equations, I don't have the product AB as a unit, right? And I can see here in my answer choices, right, that everything is expressed in terms of x's, y's, x squareds, and y squared. So there are a couple of kind of cues or indicators even among our answer choices that can help guide the direction we take this question. So let me ask you this. How am I getting to the point where I solve for AB as a unit? What can I do with this information if I know that A plus B equals x and A minus B equals y? What might I do to get a little closer to isolating AB, the product, as a unit? Anyone want to jump in and let me know where we want to go with this question? Well, if we have, that's okay, no worries. So if we have a level of understanding around, if we know to look out for those common algebraic equations, well, once again, I'm in a position to where I know that A plus B doesn't hold this as a unit. Yes, that's exactly right. I want to square both sides of both of these equations because I know when I square these equations, when I square a sum, when I square a difference, I'm going to be able to start to draw conclusions accordingly. In this case, if I take A plus B and I square it, I know I get the square of the first term plus 2 times the product plus the square of the second term. And I know that with my second equation here, if I square both sides, I get to the square of the first term minus 2 times the product plus the square of the second term. So now that I've gotten to this point, now that I've at least involved the product AB in what I'm doing here, what can I do to try to isolate AB in terms of x and y? Because I don't have any a squareds or b squareds in my answer choices. What can I do to isolate AB to get rid of these a squareds and b squareds and put it in terms of x and y? And I will say this may ring a very familiar bell from a recent past question. Yeah, we're going to subtract here, right? Because if I subtract, my a squareds cancel, my b squareds cancel, and I end up with 2ab minus a negative 2ab, which gets me to 4ab. And I know that 4ab is equal to x squared minus y squared. And now I'm one short, simple step away from solving to isolate AB. I divide both sides by 4, and AB equals x squared minus y squared over 4. So very nicely done, those of you who chose answer choice C. And yes, admittedly, there are different ways that we can route through this question, route through the algebra and draw conclusions. But in many cases, looking out for where the information's been given to us in a less than ideal manner and how we can draw conclusions accordingly allows us to solve efficiently through questions like this one. And in this case, yeah, we can solve for A and B individually. In other cases, you will encounter situations to where recognizing versus not recognizing those common algebraic equations can be make or break on questions. So certainly, again, there are alternate routes we could take through this question. I find recognizing and looking out for and knowing to look for this A and B individually to be extremely valuable, especially when we take this content area and we overlap it with elements like solving for diagonals versus lengths in geometry. Really, really commonly applied in cases to where we wouldn't necessarily otherwise have enough information to route through. In this case, we did, to be fair. In other cases, that may not be the situation. We want to make sure we're prepared and that we recognize how we can make the math a little simpler by seeing these common structures. And so we want to note here that when we have this collective is the objective, right? It does work for problem solving. And admittedly, yes, it won't always be the most efficient path through the answer. In some cases, it will flat out be easier to solve individually. In others, solving for the collective cuts down on a number of steps and may, in some cases, be the only way to route through things. You guys may have encountered situations in your practice to where you were asked to solve, let's say, for two unknowns in an equation, but you were only given the single equation to do so. Or maybe you were asked to solve for two unknowns out of 3, but given only 2 equations, and we're in a situation to where maybe integer constraints or the divisibility of the question allowed you to draw conclusions without necessarily needing that usual case rule, that usual process that we might take through the question. So we want to make sure we're on the lookout for that. And again, that we kind of build on the tools in our toolkit so that we have multiple potential approaches we could take through any given question so that we're able to take whichever is most efficient in any given case that we encounter, because in many cases recognizing common structures makes things a bit quicker. So a couple of big picture elements, right, that I want to make sure that we're keeping in mind here. So when we have data sufficiency question that tasks us to answer a collective unit of information, we want to make sure we're just trying to answer what the question is asking, not absolutely everything about the situation at hand. And we want to look out for the fact that primarily data sufficiency is a resource management question type, right? It's asking us to manage our resources and to let the question know when we have enough information to answer the question versus when we lack that information. We want to look for ways to isolate the collective that's being asked for along the way, and we want to look out particularly for exceptions to the usual case approach or pattern, because I will say I have a lot of students who gain a very decent level of success using pattern recognition to their example, having one way that they're really super comfortable with moving through questions. But I will say there are cases to where no matter how strong you are in algebra, algebra is just flat out not the most efficient path to the answer. There are other cases to where it's hands down more efficient, and we grab those students that are using number picking or using back solving as their primary strategies, and it puts them at a disadvantage. So we want to look out for and make sure that we're building in general on different ways we can think about and address questions so that we're able to tackle those exceptions to the usual case approach or pattern. So whether we're addressing data sufficiency, whether we're addressing problem solving, we want to make sure that when that collective is the objective, we're looking out for ways to solve for that sum, for that product, for that difference together where possible, rather than necessarily looking for each element alone. So thank you guys so much for joining me, especially those of you who waited a little bit to do so. I'll hang out in the chat to answer any questions you may happen to have for me along the way. I'll actually be rejoining you guys on Friday to talk about how data and statistics work their way into critical reasoning questions and what we can do about it along the way. It's actually one of my favorite topics to talk about, and I know I kind of abuse that term or have already in this particular lesson, but I hope to see you guys back again then. Thanks once again for bearing with us on the tech difficulties end of things, and happy studying in the meantime.